Hello students, today we are going to start with the most important chapter of 12th class in organic chemistry, P block elements. From this chapter we can expect give reason type questions, complete the equation type questions, to draw the structures of various compounds. So these are the type of questions asked from P block elements. We can also expect word problems, 5-mark question based on P block elements. So now when we can call any element as a P block element, or when we can give a tag of P block to any element, when the last electron enters in P orbital, or I will say P subshell, then that element will belong to P block element. For example, nitrogen with its atomic number 7 has the configuration, outermost configuration 2s2 2p3. So the last electron is entering in P orbital and therefore nitrogen belongs to P block element. Let us study the exact location of P block in the modern periodic table. So in modern periodic table, we know these two groups, they belong to S block elements. This part is called as the D block element, and group 13 to group 18 elements, these are assigned as P block elements. Now as you can see, there are total 1, 2, 3, 4, 5 and 6 groups in P block element. Now the question is that why we have 6 groups in P block elements? We know in P orbital, how many electrons can be accommodated? 6 electrons can be accommodated. The number of electrons which can be accommodated in a particular orbital, this is a subshell, that is equal to the number of groups present in that block, and therefore we have 6 groups in P block. Group number 13 to group number 18. So this is P block with group number 13, 14, 15, 16, 17 and 18. Out of which group number 13 and 14, these two we have already studied in class 11th. So now we are supposed to study group number 15, 16, 17 and 18. Out of 6 groups present in P block element, group number 13 is called as boron family. Group number 14 is called as carbon family. Similarly, group number 15 is known as nitrogen family. Group number 16 is known as chalcogens. Group number 17 is known as halogens, and group number 18 is known as noble gases. Now all these P block elements, they have the general configuration NS2NP3. NS2NP1 to 6, where N stands for the period number and N can be any period from number 2 to 6, and therefore we can assign the configurations. Group 13, it will have NS2NP1. Group 14, general configuration is NS2NP2. Similarly, group 15, NS2NP3. 16, NS2NP4. And group number 17, NS2NP5. Group number 18, NS2NP8. This will be the general configurations of these groups. For example, nitrogen, it has the configuration 2s2 2p3 and it belongs to group 15. P block element is the most versatile group where you can find metals, non-metals as well as metalloids. So P block is the only group, it is the only block where you will have all these varieties. For example, aluminium, gallium, indium, thallium, lead, bismuth and polonium, these will be metals. Elements like silicon, germanium, arsenic, selenium, antimony, tellurium, they will be metalloids. That is, they will be showing the properties of metal and non-metal both, and the remaining will be called as non-metals. So we'll have metals in these groups. as well as we have metalloids in these groups. And the remaining elements, boron, carbon, nitrogen, oxygen, fluorine, etc., all these are non-metals. So variety of elements in P block. We have to study group 15, 16, 17 and 18 in 12th class. So we'll begin with the first group, that is group number 15. Which are the elements that are present in group 15? Nitrogen, phosphorus, arsenic, antimony, bismuth. This will be a radioactive element. How to remember the elements? Nahi pata aise sab bhai. So we can easily remember the elements: nitrogen, phosphorus, arsenic, antimony and bismuth. Now whenever we have to study certain group, then we have to study the elements present in that group, its physical properties of all the elements of that group, the chemical properties, and certain compounds present of that group. When we are discussing physical properties, we'll be discussing oxidation states also. So we'll begin with group 15. So group 15 elements are nitrogen, phosphorus, arsenic, antimony and bismuth. The atomic number increases gradually down the group. So it's the first property. Atomic mass also increases gradually down the group. If we look at the configuration, nitrogen has configuration 2s2 2p3, phosphorus 3s2 3p3, arsenic 3d10 4s2 4p3, antimony 4d10 5s2 5p3 and bismuth 4f14 5d10 6s2 6p3. So for nitrogen and phosphorus, the configuration is the general one, but along with the introduction of d orbital and f orbital in arsenic, antimony and bismuth, lot of other properties will be affected. Because d and f orbital being larger in size, they will give shielding effect or screening effect. So as we have noted just now, the outermost configuration is ns2np3, and this np3, it becomes exactly half filled, and therefore it makes these elements extra stable, and therefore their other physical properties will be also different from the expected trend. The next trend is atomic radii. We know what is the meaning of atomic radii. It is the distance between the nucleus and the outermost shell of an isolated gaseous atom. According to the normal general trend, the atomic radii increases in size down the group. So as we move from nitrogen to bismuth, the atomic size will increase. But there will be certain exceptions over here. From nitrogen to phosphorus, the increase is quite considerable, but if we move from arsenic to bismuth, there will be a small increase. And just now we have seen that arsenic to bismuth, there is introduction of d or f orbital, and it results in shielding effect or screening effect. And that's why it results in smaller increase in size. As we can see in this, the covalent radii, nitrogen 70 to phosphorus 110 picometer. So there is a great increase in size. But when we are moving from arsenic to antimony 121 to 141, there is only a slight increase. And when we move on to bismuth, the increase in size becomes much more smaller because of presence of 4F, which will produce screening effect. The next trend is ionization enthalpy. What is ionization enthalpy? The energy required to remove an electron from its outermost shell. And we have already studied its trend in class 11, that ionization enthalpy decreases down the group. Why? Because there is increase in the atomic size. But in case of group 15, the things becomes little bit different because there is extra stable half-filled p orbital. And as a result, their ionization enthalpy becomes greater than that of group 14 elements. So IE of group 14 is less than IE of group 15 elements. The first reason is the half-filled p orbitals, and second reason is the smaller size. And obviously first ionization enthalpy will be less than the second one, and second ionization enthalpy will be less than the third one. Let us look at the data available. Ionization enthalpy of nitrogen is 1402 kilojoule mole inverse. When we move to phosphorus, the value decreases. When we move to arsenic, the value decreases. Similarly to antimony and bismuth, the decrease is continued. If we look at the values of second and third ionization enthalpies, they are much higher than their previous ionization enthalpies. If we consider the trends of boiling point, the boiling point continuously increases from nitrogen to phosphorus to arsenic to antimony and bismuth. But in case of melting point, it increases till arsenic, then it suddenly decreases at antimony, and again it decreases at bismuth. The density also increases from nitrogen to bismuth. The next property that we are going to discuss is electronegativity. What is electronegativity? It is a tendency of a bonded pair where an element will attract the shared pair of electron towards itself. Now the electronegativity value decreases down the group, but we know that nitrogen is the third most electronegative element. So nitrogen is third most electronegative element. Coming to physical properties. How do these occur? All the elements are polyatomic in nature. Dinitrogen is a diatomic gas, that is nitrogen exists as N2. Phosphorus exists as P4. Arsenic, antimony and bismuth, they are monoatomic molecules. The starting two elements, nitrogen and phosphorus, they are non-metals. Arsenic and antimony are metalloids, and bismuth is a metal. Now why the metallic character is increasing down the group? Because there is a decrease in ionization enthalpy and increase in atomic size. What happens as the atomic size increases? As the atomic size increases, the tendency to lose electrons increases. That is, ionization enthalpy increases. And we know ionization enthalpy is directly proportional to metallic character. Inversely proportional to metallic character. Lesser the ionization enthalpy, higher will be metallic character. Bismuth, as we have already seen, the least IP in group 15, and therefore it will be more metallic in character. If we talk about the occurrence, nitrogen, it exists as N2 and it occupies near about 78% volume of atmosphere. In the atmosphere, it exists as nitrates in the form of proteins or in the form of proteins of plants and animals. Phosphorus, it exists in the form of phosphates. Phosphorus is an essential component of plant and animal matter. The remaining element like arsenic, antimony and bismuth, they exist in the form of minerals. So that was the general introduction of group 15 that we have discussed today. In our next video, we will be discussing about nitrogen and its various properties. That's all for the day. Thanks for watching. Have a nice day.